Ever wished for the ultimate shortcut? I'm not talking about just getting across town. I mean across the entire planet. Today, we're diving into a really wild thought experiment. What if you could just fall straight through the center of the Earth? I know, it sounds like something straight out of a movie, right? Forget planes, forget trains. Just imagine a tunnel, a direct shot from one side of the globe to the other. All you'd have to do is jump in and let gravity take over. So what would a trip like that actually be like? And the payoff? Oh, it's absolutely incredible. Think about it. A trip that normally takes a jet plane around 22 hours could, in theory, be cut down to just 42 minutes. That's probably less time than your morning commute. The appeal is pretty obvious, right? But the physics, well, that's where things start to get really, really interesting. Okay, so right off the bat, we hit a huge problem, a major snag. See, you can't just dig a tunnel anywhere and expect this to work. If you tried, your journey would be over in a matter of seconds. And no, not because you made it to the other side. So what's the culprit? Well, it's a force you've probably heard of, the Coriolis effect. To put it simply, because our planet is constantly spinning, any object moving freely across it, like you falling through a tunnel, gets pushed off a straight path. Here's a great way to think about it. Imagine you're on one of those spinning merry-go-rounds at a playground. If you try to throw a ball to your friend on the other side, it's not going to go straight, is it? It's going to curve. The Earth is basically just a giant, super fast merry-go-round. So you jump into your tunnel, but here's the thing, the Earth doesn't stop spinning for you. It keeps rotating underneath you from west to east at something like 1,670 kilometers an hour. So while you're falling down, the east wall of that tunnel is rushing up to meet you, and bam, within seconds you'd slam right into it, trip over. But what if there was a way to get around that sideways force? Well, there is. If we dig our tunnels straight from the North Pole to the South Pole, right along the Earth's axis of rotation, that Coriolis effect basically disappears. It becomes a non-issue. This is where our real journey can finally begin. All right, here we go. You jump in at the North Pole. Instantly, you start accelerating downwards at that familiar rate, 9.8 meters per second squared. It's the exact same force of gravity that's holding you in your chair right now. But the difference is, this time there is absolutely nothing to stop you. You start picking up speed, like unbelievably fast. So fast that it would only take you about 13 minutes to get to the very center of the Earth. Let that sink in. A journey of over 6,000 kilometers in less time than it takes to watch an episode of your favorite show. As you're just rocketing towards the core, your speed would eventually peak at a truly mind-bending 28,000 kilometers per hour. That's more than 20 times the speed of sound. You'd be falling faster than any human has ever traveled inside our atmosphere. Just incredible. And then, for just one incredible moment, you're there. The exact center of the Earth. And this is where something truly amazing happens. You've got the entire mass of the planet pulling on you equally from every single direction. All those forces just cancel each other out. For a split second, you'd feel completely weightless, just floating right in the heart of the planet. So let's look at the beautiful symmetry of this whole trip. At minute 0, you jump. By minute 13, you're at the core, hitting that top speed. You blow past the center at 21 minutes. And then, the whole thing just reverses. The gravity of the half of the Earth you've already passed starts pulling you back, slowing you down. You decelerate at the exact same rate you sped up, and you pop out at the South Pole right at the 42-minute mark. You'd stop for just a tiny instant before gravity would, you guessed it, pull you right back in for the return trip. It's such a beautiful, elegant idea from a physics point of view, isn't it? But now it's time for a little reality check. Because as fascinating as this all sounds, this journey is completely, utterly, 100% impossible. So let's just try to wrap our heads around the scale of this thing. Our tunnel needs to be over 12,000 kilometers long. You know what the deepest hole we've ever actually dug is? It's the Kola super deep borehole in Russia. And it's only 12 kilometers deep. 12! We haven't even really started to scratch the surface. Literally. And the biggest reason we had to stop digging, and the reason this whole tunnel idea is a non-starter, it all comes down to one simple thing: heat. The deeper you go, the hotter it gets. And at the Earth's core, we're talking about a blistering 6,000 degrees Celsius. So just how hot is 6,000 degrees Celsius? Well, it's about the same temperature as the surface of the sun. Yeah, there is no material we know of that could even come close to withstanding that kind of heat. Our tunnel, and anything in it would just melt. Okay, so digging through the core is out. But what if we didn't have to? Let's push this thought experiment one last crazy step further. What if the Earth was just hollow? Yeah, a hollow Earth wouldn't solve any problems. In fact, it would be a total catastrophe. For starters, our planet's magnetic field, the one that protects us from all the sun's nasty radiation, that's generated by our molten core. So without it, we'd be fried by deadly UV rays. And inside this hollow shell, gravity from the crust would be pulling on you from every direction at once, so you just float there. Oh, and also, there isn't nearly enough air in our atmosphere to fill that massive space, so you couldn't breathe anyway. Bottom line, we really, really need our solid core. See, our planet is the way it is for a very good reason. That impossibly hot, dense core, that's the very thing that makes life up here on the surface possible. Which really just leaves us with one final big question. If we could somehow, against all odds, overcome the insane heat and pressure, what other strange physics and mind-blowing discoveries are waiting for us on a real journey to the center of the Earth?